Good day, viewers. This is Afiademola Johnson, the chemistry tutor. Don't forget to share this video, to like it, and to put comments where you need me to improve. So please do remember also we have started a physical class for JAM, for PVM, for WIDE, NECO by 5 to 7 p.m., 7:30 p.m. at Christ Academy, Kilometer 8, Sapler Road, Benin City. So, and try to click the subscription button to subscribe. So, on the series of carbohydrates that we have been talking about, I want us to talk about sucrose. Sucrose chemistry. The chemistry of sucrose. The chemistry of sucrose. Like you have seen, sucrose is this. This is your table sugar. The one you use to prepare tea. This is your table sugar you use to prepare tea. This one, that is sucrose. So that is sucrose we are talking about here. Now, and we have talked about the structure of the sucrose in a previous video we have done. Now, to talk about this, what do we need to talk about now? We need to talk about the preparation. How do we get it? Preparation of sucrose. Now, sucrose is extracted from sugarcane juice. Now, to do that, the sugarcane juice, the sugarcane, you can also get it, or sugar beet stem is first shredded between rollers, as if you grind it. And as you are grinding it, as pressing it, the sugarcane juice is coming out. So the sugarcane juice is then extracted with water, boiled or heated to the temperature of about 80 degrees centigrade. So the reason I did not use boil here is that the temperature at which water boils is 100, not 80. So it will not boil, but it is warm. So as you are shredding the stem, the juice that's coming out to allow it to enter inside the hot water and it dissolves in it. Then the next thing to do is to purify, is to then bubble carbon 4 oxide and slate line through the resulting solution. Why are you doing that? To purify it. So then after that, the next thing to do is to concentrate the solution by evaporation with heating. So you heat it so that the entire solution loses some amount of water and it becomes more concentrated. Then the solution, the concentrated solution is then allowed to get cooled. So as it gets cooled, so crystals of sucrose with impurities will be what? Will be noticed. So the crude sugar will be reddish brown. Reddish brown. So then, after getting that, what then do you do? So the resulting solution is purified again with CO2 and slaked lime, after which the brown crude sugar would be what? Would be bleached. Would be bleached using animal charcoal. So that is it. So that is how to prepare sucrose. Then the next to look at now, what are the physical properties? Physical properties of sucrose. Number one, it is a colorless solid which with what? With very sweet taste. That's a very sweet taste. How many of you have tasted sugar, table sugar they use to prepare tea? Very sweet. Then another thing is that its solution is neutral to litmus paper, showing that it is neither acidic nor alkaline. So it dissolves in water. That is why it's a complex sugar. Don't forget, we said sugars are carbohydrates that have sweet taste and can dissolve in water. So these are the general physical properties of sucrose. Now let's look at the chemical properties. So the chemical properties of sucrose are: number one, we have action of heat. Number two, we have dehydration reaction. Number three, we have fermentation. Number four, we have reaction as a non-reducing agent. It's a non-reducing sugar. So now let's take them one by one. The first one is action of heat. Action of heat on sucrose. Action of heat on sucrose. We are going to demonstrate that now. So when sucrose is heated strongly at about 255 degrees centigrade. Now, at about 255 degrees centigrade, now when the melting point has not been reached, what happens? Sucrose melts. I mean, when it's shining point, there's something called shining. I'm going to talk about that one. Sucrose melts to form a yellow liquid. A yellow liquid called caramel. Caramel. So, used in confectionaries. Confectionaries for sweetening of food. Now, then take note of one thing. Then when you now further eat it, so further eating gets it dehydrated to form black sugar charcoal. And this final property is called shine. Shining of sucrose. Now, see what we are talking about. Sucrose, we have discussed the formula before. You have C12, H22, O11. So when it is strongly heated, then 11 molecules of water leaves minus 11 H2O. Then when you do that, 11 times 2, that's 22 hydrogen, all this one goes. 11 oxygen, this one goes, then you are left with 12 molecules of carbon, which is sugar charcoal. Now let's demonstrate what we are talking about here. So let's have the sucrose in a boiling tube. And let's ignite the gas. So let's wash. You can see the color of the sucrose before eating. So now, when eating, let's observe the color change of the sucrose. So when it gets to 225 degrees centigrade, it turns yellow liquid. And that yellow liquid is called caramel. You can see it's already forming. The caramel is already forming. So, you can see it. You can see the caramel. That's a yellow liquid. So this one is used in confectionaries for making sweets or candies. So that's confectionaries. So you can try to eat it wherever you are and perceive the odor. You see, it has sweet smell. Then when you further heat it, then sugar charcoal will be formed. Sugar charcoal will be formed. So that is that. H2SO4. So then the next thing to look at is dehydration. Dehydration of sucrose. Already, that was the final thing we did here. So, but this one is taking place catalytically. Dehydration means the removal of hydrogen and oxygen in 2:1. You know that's we are saying that removal of water 2:1, 2 atoms of hydrogen, 1 atom of oxygen. So that is that. Now, so if in the presence of conc H2SO4 or concentrated tetraoxosulfate 6, acid, which is H2SO4. Now, sugar generally, sugars now gets dehydrated as they lose hydrogen and oxygen in the ratio 2:1, and then forms black carbon called what? Called sugar charcoal. The same equation we have here is still this. So if two things that can cause dehydration are strong heating and the addition of conc H2SO4. Let's look at that. Don't worry. Now, okay, let's watch what we are talking about. This is sucrose and this is conc H2SO4. So let's pour. So you can see the color change as the color is changing. Can you see? As the color is changing, you can see that. So it's turning already to sugar charcoal. It's becoming black gradually. So that is dehydration has taken place. The sucrose has lost all the hydrogen it has, all the oxygen it has. It's now left with what? Carbon, black carbon. So that is what you can see there. Now, let's move on to the next one, which is now fermentation. Fermentation. So that's to tell you that fructose can also be used to carry out fermentation. So in the process, the sucrose is first hydrolyzed. Hydrolyzed by an enzyme called invertase, secreted by yeast. to form what? To form glucose and fructose. So now, what am I saying? You have C12H22O11. So now if you add yeast, the yeast gives invertase, enzyme invertase. Then it forms two molecules of C6H12O6, which is glucose and what? And fructose. So now, that is what we have there. Now, and take note of one thing. The hydrolysis of sucrose. Now, by enzyme invertase is often called inversion. It's called inversion. So now that's why enzyme invertase is used. Now, either of the glucose now, the glucose or the fructose would finally be fermented by enzyme zymes to form ethanol and liberate carbon 4 oxide. So, what do we have there? So what we have there is that we have C6H12O6, which is either glucose or fructose. Either of them, in the presence of yeast, which produces enzyme zymes, then we now have two molecules of C2H5OH plus two molecules of carbon 4 oxide. So fermentation is said to have taken place. So now let's look at the reaction as a non-reducing sugar. As a non-reducing sugar, now, why is sucrose not a reducing sugar? Sucrose is a non-reducing sugar. Unlike lactose and maltose, which are reducing sugar. Why? Because of the presence of beta 1 to 2 linkage in its molecular structure. Now, what am I talking about? Let's see this. So, then what do you need to do? Now, and because of that, the carbonyl group of